Feldon. This is Algebra 2, Chapter 5, Section 3. This is Part 2 of the video. So we're starting on page 4. So again, this is the list of the transformations that we had used previously in Chapters 1 through 3 and the first part of this lesson. So you should know those right off the hand. So the idea is, regardless of what the radical function is, you should be able to tell me what the transformation is based on what the original parent is. So the minus 2 on the inside, it's inside, so it affects x. It's adding or subtracting, so that's a translate. So this is going to translate right 2 units. And again, you should look at the rules above if you don't remember them. If you add a 7 to the outside, outside is y. So that's going to translate up 7 units. Remember, inside x, outside y. All right, we have a negative in the inside. Negatives are reflections, so it's going to reflect. Right, so this is the one that people mess up. If you're in the inside, you affect x. If you change your x value, then you're reflected on the y-axis, right? Right, because if you change your x value, you went from positive to negative or negative to positive y value, right? So you went over the y-axis. All right, if there's a 3 in the inside, multiplying is a scaling. It's in the insides, it affects x, so it's a horizontal. And it's counterintuitive on the insides. This is a horizontal shrink by a factor of 3. Okay. All right, next one. It's a 4 on the outside being multiplied. Outside is vertical. So it's a vertical. It's multiplied by 4. So that's a stretch because it's straightforward and it's on the outside. By a factor of 4. Pause the video, try the student problems. Okay, inside is x, so horizontal. It's adding and subtracting, so that's translating. So it's horizontal, or I'd say translate, I guess. Left 3 units, because it's counterintuitive inside. Okay. If it's on the outside, it's y, so it's adding and subtracting, so that's translate or shift. 1 unit down. Okay. And dividing by 2 on the inside, or multiplying by 1/2, whichever one you want. Inside is horizontal. It's counterintuitive inside, so dividing by 2 is really stretching. It's a horizontal stretch by a factor of 2. So basically your y value is changed by a factor of 2. All right, if it's on the outside, that's vertical because that's y. Vertical shrink, because multiplying by 1/5 is a shrink if it's on the outside, because it's straightforward, by a factor of 5. So all the x values are divided by 5. So we have a negative, which is a reflection. So it's a reflection on the, what's on the outside, you're affecting y. If you change your y value, you're reflected on the x-axis, right? Think about it. You changed your y value from here to here. You went over the x-axis, okay? All right, let's go to page 5. All right, so as we talked about before, the order of operations is the order of transformations, okay? So you must horizontal translate, stretch or shrink second, and reflect, and then vertical translate last when doing the graphing. So some of these are even roots, some of these are odd roots. So if you see a 1/4 or a 1/5, remember that can also be written in radical form. So move that down. There we go. So this is really the 4th root of x minus 2 plus 3. So essentially I have a translate up because it's on the outside adding and subtracting. And I have a translate right because what's in the inside is x, right? And it's counterintuitive. So which one comes first? That's horizontal translation. That's vertical translation. Horizontal comes before vertical because horizontal is step 1, vertical is step 2. So typically, your graph would look like this for an even root, but I have to go right 2 and up 1, 2, 3. So that is my new graph. Let's erase the extra junk we don't need from before. So what is the resulting domain and range? Well, the farthest I can go left is 2. I can get there, so I put a bracket, and I go to infinity. The farthest down I can go is 3, which I can get to, so I put a bracket, and it goes up to infinity. Okay, so the next one is a fifth root, or 1/5 power. So it's a fifth root of negative 2x and a minus 1. So that is a translate down. Since it's on the outside, it's y. The 2 is a scaling. In this case, it's going to be a shrink horizontally, because inside is x, that's horizontal. So multiplying by 2 is actually a shrink, because inside is counterintuitive. And then we have the negative, which is a reflection on the, well, inside is x, so you're changing your x value. So if you change your x value, you were shifted over the x of the y-axis. So going through the order of transformations, that's number 1, that's number 2, that's number 3. So that's our typical odd root. So if we shrink it, it's just going to shrink. That doesn't really change anything, right? Reflect on the y-axis is going to make me go the other way, though. Okay, so reflect on the y-axis, that one over there, this one over here. But then I went down 3, 1, 2, 3. So now I'm really going to be like this, right? Okay, so let's erase all that extra junk there. So I went down 3, but I reflected the other way, so I'm really going like this, right? Again, we're making a sketch here, not an exact graph with tables, because all we need to know is domain and range, which it goes forever left, forever right, and forever down and forever up. Because remember, the odds don't have restrictive domains and ranges. You can do odd roots of any number you'd like. Pause the video, do the next two problems. Okay, so next one is an even root. So that's -2 6 roots of x plus 3. So the inside plus 3 is a translate left, and the outside 2 is a scaling. So it is a stretch since it's on the outside, and it's vertical. So we're stretching y because it's on the outside, and then this negative on the outside is reflection. So we're changing the y values, and we must reflect on the x-axis. If you change your y, it went over the x-axis. So what comes first? Translate horizontal comes first. Stretching vertically comes second, and reflecting comes third. There is no horizontal vertical translation, which would be the fourth step here, according to the list up above. So typically our graph would look like this, standard even root, but we have to translate left 3 units, 1, 2, 3. So now it looks like this. And we have to stretch it. That doesn't really do much. And then reflect it on the x-axis just makes me go the other way, doesn't it? Okay, so we can erase all the extra junk here. Again, not to scale. What's important is that the tail starts at -3 and it tails off into the rightward direction. So the least I can go left is -3, but I'm going forever in the right direction. The highest I can be is 0. The lowest I can be is -infinity, though. So I can get to 0 and I can get to -3, hence the boxes. The second problem is the seventh root of 1/2 x minus 1. So the minus 1's on the outside, so that's vertical y. So we're going to translate up. So it's a vertical translation. The 1/2 on the inside is a scaling, but it's actually going to be a stretch because it's counterintuitive on the inside. Stretch horizontally because the inside is x. So typically the graph would look like this. Horizontal stretch, which is scaling, happens first, and translating up happens second, because horizontal stretch is the second step in the order of operations, the order of transformations, and translating vertically is the fourth, so that happens last. So if I just stretch it, that's not going to do a heck of a lot, right? But translating up to will. Okay, so that gives us our new graph up there. And again, keep in mind that the stretching and the shrinking does not make any difference for the odd or the even roots. Okay, so our domain and range is unrestricted for the odds, so you can go in any direction you'd like. You can make these more exact if you'd like to by doing tables of values, but it's not going to change very much. That's up to you if you want to get more exact, but I'm only looking for sketches, domains, and ranges. That's the end of part 2.